In this slide cast and the one that follows, we're going to take that work breakdown structure, which is definition of the scope of the project, and we're going to turn it into a program which will tell us how we're going to build a project, an engineering project. We start with the work breakdown structure. So this defines the scope of the project. Remember, we took the road, we broke it into carriageway and berm. We broke the carriageway into road these three. We broke the berm into these three. Very simplistic, but it will do for what we want to do. We're going to compose what's called a network diagram composed of the lowest levels of the work breakdown structure. Notice that these ones here aren't really included in our network diagram. And here it is. So the project starts, we need to build the road formation so that we prepared the earthworks, we put down the aggregates, then we seal the road. Once we've done that, we can start building the footpath, and we can start doing the curb and channel. Once the curb and channel is complete, we can do the road markings. Likewise, once the footpath is complete, we do the driveways. Once the driveways are complete, we do the grassed areas. Once these two are complete, we've completed the project. As I said, it's simplistic, but that's what we need to do at present. So the concepts I want you to get from this is dependency. Dependency is the order in which the activities need to proceed. So this needs to happen before, this needs to happen before this happens. 2.2 needs to happen and be complete before 2.3 starts. So that's what dependency is. The predecessor, that's these, in each one of these relationships, each one of these arrows shows a dependency. The one that's the first one, the activity that needs to happen before the other one, is called the predecessor. So for example, 1.2 is the predecessor for 1.3. 1.2 has to finish before 1.3 can start. That's what it means. Conversely, 1.3 is the successor to 1.2. So after 1.2 is finished, the successor 1.3 starts. Notice that you can have multiple predecessors and successors. So for example, 1.1 is the predecessor for both 1.2 and 2.1. So once this is completed, both of these tasks can start together at the same time. Likewise, project finish is a successor of both 1.3 and 2.3. So this one cannot start, well in this case the project is not finished until both 1.3 and 2.3 have been completed. Let's look at the way it works. So there's two different paths here. There's project start to 1.1 to 1.2 to 1.3 to the project finish. Or there's project start 1.1, 2.1, 2.2, 2.3 project finish. So this path is going to take 4 weeks. So project start to 1.1 to 1.2 to finish. This path that's shown in red is going to take 5 weeks. Now remember, these activities here, 2.1, 2.2, 2.3, can happen at the same time as 1.2 and 1.3. So you could have 2 crews working on it, one crew doing this and the other crew doing that. This crew here, the crew doing the 1.2, 1.3, they could be delayed by a week and the project finish would still be the same. This crew here, if they're delayed by a week, the project finish is going to stretch out by a week. So that means that this one here, it's going to take 5 weeks, is what's called the critical path. It's called the critical path because every one of these activities on that path are critical to the completion of the project. If any of them are delayed, then the completion of the project is delayed. So here's the definition. The critical path is the series of activities that takes the longest time. So it's critical. So you've got project start, road formation, footpath, driveways, grassed areas, and project finish. They are the critical path for this particular project. And they are the critical activities. So the critical path is the critical activities all joined together. Notice that there are also non-critical activities, these ones here, 1.2, 1.3. They are not on the critical path, so they can be delayed by a certain amount and the project finish would not be affected. However, if say curb and channel was delayed by 2 weeks, then all of a sudden the critical path shifts from the red path to the blue path, and so now the curb and channel becomes a critical activity. So critical activities are flexible. Now you can see that this is quite a good way of defining the project. You want the project to finish at a specific time. You want to identify which activities are the ones that we need to be stressing need to be completed on time. If one of these are starting to fall behind, we need to put extra resources in to complete them on time, because we know that if we run over time, we're going to finish late. We're not going to achieve our objective of finishing the project on time. But if say curb and channel is running a little bit behind time, if it's going to be a few days late, we're not going to worry about it as much, because we know that it's not going to affect that project finish. So that helps us prioritize to identify what the main problems, what the main activities are going to be. Now in the next slide cast, we're going to look at taking this and turning it into a plan for the time management of the project.